Okay, so we're going to talk about section 4.4, which continues with this idea of taking a sine wave, taking a cos wave, and doing transformations to it. In the last video, we talked about what this A is, and that is your amplitude. How high and how low does it go? It's just like your vertical stretch when we were doing a parabola. And in order to figure it out graphically, you multiply your y values by whatever number is there. So that is what your A is for. Your A is your amplitude, which is a vertical stretch. So if you've got like a 4 there, it's a vertical expansion by 4. If you have like a fourth there, it's a vertical compression by a fourth because it's going to vertically smush it by a fourth. So then we talk about what the B was for. Oh, sorry, that's my dog coughing. Then we talk about what the B is for. The B is not your period, but it is your horizontal stretch. You use B to figure out your period because period is 360 divided by B, or if you're talking radians, 2 pi divided by B. In order to make that happen on the graph, you divide. It's very important that you divide your x values by whatever number that is. So if there's a 2 there, you divide all your x values by 2, which would make it a horizontal compression by a half. Your wave is going to be half as long as it was. Okay. So those are the two that we talked about in the last section. But as you can see, I've got 2 more numbers on there. I'm going to skip C for a minute, and I'm going to go to D. D is your vertical displacement, just like it was, just like it was with a parabola. If that's +3, you move the wave up 3. If it's -3, you move it down. So positive means you go up, negative means you go down. All right, so that is for your D. Then we get to C. C used to be your horizontal displacement. You would move it left or right. It's the same thing, but they give it a new name just to confuse you. They now call it something really fancy called your phase shift. This is just a fancy word for your horizontal displacement. And again, it works exactly like it did before when we were doing a parabola. Minus means that it moves to the right. Positive means it moves to the left. All right, so it's exactly the same. So our A is multiplying y values, our B is dividing x values, our C is moving horizontally, so moving your x values across, and your D is your vertical, so it's moving your y values up and down. Okay, so I'm going to do example number 1 on page 213. Now, they do it in radians. I think better in degrees, so I'm just going to switch it to degrees. You can do that. It's no big deal. All right. Now, they want us to graph, and I'm going to put it, I think, in red. That will be my final. They want us to graph y, we'll put it over here, y is equal to 3 sine x minus 120 degrees. They have 2 pi over 3. I just changed it into degrees. Minus 2. That's what they have. And they want us to draw this. Most people are not going to be able to draw that whole thing right at the beginning. So just like with the parabola, we're actually going to draw this in stages. So I'm going to do it in a bunch of different stages. So here we have, I'm going to say 360s right about here. And we'll do, this is 1. Woo! This is 1, this is 2, this is 3. This is -1, -2, and -3. Please ignore my crazy lines. So this is 180 degrees. This is 90. This is 270. And there's 360. Imagine they're evenly spaced. Again, I would be making it, you should do this on graph paper. It makes your life way easier, so that each square is worth 30. So it'd be 30, 60, 90, 120, 150, 180, 210, 240, 270, and so on. So the first thing I'm going to graph is I'm just going to graph y is equal to sine x. Just a plain sine x graph with none of this crazy stuff around it. Okay? If I do that, sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, which is right around there, and sine of 360 is 0. So I end up with just a regular old sine wave, no biggie. Okay, so the next thing I'm going to graph, let's do it in purple, I like purple, is I'm going to graph y is equal to 3 sine x. So if I was giving information rather than graphing this, I would say that the amplitude is 3. I'm going to multiply my y values by 3. So 0 times 3 is still 0, but 1 times 3 is 3. 0 times 3 is still 0, but -1 times 3 is -3, and 0. So that we have vertically, whoa, that was wonky. So we have vertically stretched it by 3. So now I'm going to do, I've never done this color. Let's do this color. So now we're going to do y is equal to 3 sine x minus 120 degrees. Okay, so that minus 120 is a phase shift, and that phase shift, the minus, is going to move it right 120 degrees. Now, if you've done this on graph paper like you should be, and each square is worth 30, then you're actually going to move everything over 4 squares, because 30 goes into 120 4 times. So you're going to take this point and you're going to go over to 120. You're going to take this point, which is at 90, and you're going to go over 120, which is going to bring you to 210. And Wicket's going to stop barking. And you're going to take this point, which is at 180, and you're going to move it to over 120 to 300. So it's going to go here. You're going to take 270, and you're going to move it 120, which is going to bring you to 390. So here. And you're going to take 360, and you're going to move it 120, which is going to bring you to 4 80. So here. So now you have, trying to follow my dots, now you have here. Everything has just been moved over to the right 120 degrees. Finally, I'm going to do the last thing, and so I'm going to do the red graph. The -2 is a vertical displacement, and it is down 2. So if I asked you just to describe in words what was happening, though I would want you to say there's an amplitude of 3, a phase shift right 120, and a vertical displacement down 2. So from my green graph, I'm just going to move everything down 2. So 1, 2. I'm going to take this, which is at 3, and I'm going to down 2. 1, 2. I'm going to take this, which is at 0, and I'm going to go down 2. 1, 2. I'm going to take -3, and I'm going to go down 2. 1, 2. It's way at the bottom of my screen, so let's say there. And this is going to go down 2 to 1, 2. So right here. So that it is now here. So the red graph is your final graph. See how colors help? If you're doing this on a test, I would suggest you do colors, something, so that I know which graph is your last one. Okay. So they want us to talk about in example 2. They give us an equation, and they want us to talk about the graph, give them some information. I think they want us to graph it too. I'm just going to double check that. Okay, I'm getting there, And my dogs are barking again. Welcome to my life. Okay, so let's stick with red again as the final one. And wicket, they give us y is equal to 3 sine 2 x minus pi over 4. I'll do this one in radians. Plus 2. Wicket, you can stop anytime. So they want to know a lot of things here. They want to know what is the domain. By the way, I'm probably never going to ask that. But anyway, what is the domain? What is the range? Why is my dog sitting on the book? What is the domain? What is the range? What is the amplitude? What is the period? They ask for the y-intercept. I don't know whether we'll get that or not. I'm going to ignore the y. I'm never going to ask you for the y-intercept. The phase shift and the vertical displacement. A lot of this I can get without even drawing it. And then they want you to graph it. But I can get a lot of this without even graphing it. First off, the amplitude. The amplitude is 3 because it's right there. The period. Remember that period is 2 pi over b if we're working in radians. So my b is 2, so it's going to be 2 pi over 2. My 2's will cancel, and I will have pi. So I would love to have pi. Anyway, my period is pi. If you were doing that in degrees, that would be 180 degrees. So you're going to get one full wave within 180 degrees. The phase shift is pi over 4, and because it's minus, it's going to be pi over 4 to the right. Pi over 4, if you're thinking in degrees, is 45 degrees. Plus 2 is my vertical displacement, so it is just up 2. Now, we're going to talk about domain and range, but we're going to do that after we graph this wonderful thing. Okay, now I'm going to erase some of this so that I have some space. So if you need to write it down, just pause the video. So I need some space to draw this. So again, I'm going to do this in pieces, but I think I'll do it in less pieces this time. So, oh, right, sorry. We're going to do this in less pieces this time. So let's say, it's fine. Let's say 360 is here. Let's say 180 is here. It's halfway, right? Let's say 90 is here. And let's say 270 is here. So the first thing I'm going to graph is I'm going to graph y is equal to 3 sine x. I'm not going to worry about the other things right now, just the 3. Remember that the 3 means you're going to multiply your y values by 3. So sine of 0 is 0. And 0 times 3 is 0. Sine of 90 is 1, but we're going to take that 1 and multiply it by 3. So it's going to go 1, 2, 3. So right here. Sine of 180 is 0, and 0 times 3 is still 0. Sine of 270 is negative 1, but we're going to multiply it by 3, so it's negative 1, negative 2, negative 3. So it's like down here. And sine of 360 is 0, and 0 times 3 is 0. So we have a sine wave with an amplitude of 3. Okay. Now I'm going to graph, I like the purple, I'm going to graph y is equal to 3 sine 2x. The 2 means I'm going to divide my x values by 2. So 0 divided by 2, still 0, but 90 divided by 2 is 45. So that's actually going to come back here. 180 divided by 2 is 90, so it's actually going to come here. 270 divided by 2 is 135. So that's here. And 360 divided by 2 is 180. So it has been horizontally compressed to be half the length it was. So one wave takes half the amount of time that it did. Again, this actually keeps going in both directions forever and ever, but we're only graphing one wave. Okay, so blue. We're going to do y. So I'll just underline it. We're going to do the minus pi over 4. So pi over 4, I did this in degrees. Sorry, that's just a habit. But we can transfer that. Pi over 4 is 45 degrees. So if it's x minus 45 degrees, everything's going to move to the right 45 degrees. So this point is going to move over to be at 45. This point, which is currently at 45, is going to move over to be at 90, kind of back where it was. This 90 is going to move 45 degrees to be at 135. This point at 135 is going to move over 45 degrees to be at 180. And 180 is going to move over 45 degrees to be at 225, which is right here. So I still have this wave that has an amplitude of 3, but it's just been phase shifted. It's been moved over. So finally, I'm going to graph the red one. And the only thing I have left to do with the red one is move everything up 2. So this is going to go up 2. 1, 2. So it's here. This is going to go up 2. So 1, 2. So it's here. This is going to go up 2. So 1, 2. So it's here. This is going to go up 2. So 1, 2. So it's here. And this is going to go up 2. So 1, 2. So it's here. So same place, just moved up 2. All right. So the red graph is my final graph. So the last thing we have to talk about is domain and range. So domain, remember this goes to the left forever because this will just keep going and repeating itself. Same thing in the other direction. So x is actually any real number. Could be anything. The range, remember, talks about what my y's are. Well, it looks like the low point here is -1. And the high point is actually 5 because it was 3, but we moved it up 2. So my range is that my y has to be bigger than or equal to -1, but less than or equal to 5. It's got to be in between. Very rarely am I going to ask you to do something like that. However, there is the graph. All right. Example 3 is just another one of those. Because you can repeat this video as many times as you need to, I don't think I'm going to do another one of these because it's just the same thing. They do it with a cos wave, but everything is exactly the same. All right, no difference. All right, so I'm actually going to skip example 3 so that this video isn't quite so long. And I'm going to go to example 4. Example 4 is on page 216, and it gives you the picture. It gives you the picture, and it wants you to fill in y is equal to a cos b of, now they put x plus c, I put x minus c, who cares, plus d. And they give you a picture. Now, I'm just going to draw a sketch of the picture because the picture's there for you in the book on page 216. It goes in radians, and here, and then it kind of goes up, back down, up, back down, and it keeps on going. Now, it tells you that this is a cos wave. So there's some logical reasoning skills we're going to need to use here. All right. So the amplitude for the A, oops, sorry, that was me. The amplitude is your maximum. Amplitude is your maximum minus your minimum divided by 2. So if I look at the picture on page 216 and I look at where is this maximum, it's at 5. If I look at where is this minimum, it's at -1. So my amplitude is 5 minus -1 divided by 2. Well, that's 6 divided by 2, which is 3. So what goes here is 3. All right. The B is a little bit more difficult to get. So the B is, remember, period, and because it's in radians, period is 2 pi over B. So what we need is we need to figure out what the period is. How long does it take to go through one full wave? There's different ways you can figure that out, but the easiest one I know of is to look at the crest or the top of this wave and say, where is that? And if I look in the textbook at where is that, that is at pi over 6. Now, if you don't like it in radians, that's cool. That is 30 degrees. Same thing. Where is the next crest? Because that's like the beginning of the wave, and this is like the end of the wave, of just one wave. And then it starts to make a new wave, and it keeps going and going and going. So where is that end? So if I look, it looks like it is at 7 pi over 6. Now, I don't know what 7 pi over 6 is, but I can figure that out, except I don't have a calculator sitting right here. So let me just do 7 times 180, which is 0.56, carry the 5, so that's 1260 divided by 6, so that would be 210. Okay, so that was just me doing a little bit of quick math there, because I'm too lazy to go get my calculator. So it's at 210. So the question is, how far is it? And again, if you don't want to do this in radians over here, you don't have to. If you think better in degrees, do 360 over b. So how far is it? If I'm doing it in degrees, just because I think better, how far is it from 30 to 210? What is that distance? Well, 210 minus 30 is 180 degrees. So my period, the length that it takes to go through one full wave is 180. So 180b is 360. So b is 360 divided by 180. So b is 2. Ha, now I know what goes there. Okay, so now, next thing I have to figure out is I have to figure out the phase shift. So to figure out phase shift, what you have to do is think about what you know about a cos wave. A cos wave starts at the highest point, starts at the crest, goes down, and comes back up again. So in terms of a cos wave, this really is the start, and the start is at pi over 6. So someone has moved this pi over 6 to the right. So x minus pi over 6. Now, plus d. We figured out that the amplitude was supposed to be 3, which means if there's no vertical displacement, the high point will be 3. The crest will be at 3, but it's not, it's at 5. So if it should be at 3, but it's at 5, that means someone has moved it up 2. And so that's my answer. My answer is just 3 cos 2x minus pi over 6 plus 2. All right, I think I put the homework up for this section too, so feel free to look at that. I will try tomorrow to do quick, I wish they would be quick. I'll try tomorrow to do quick videos of the last 2 sections. Thanks, bye.